Okay, 6G is about differentiation and what says differentiation of the logarithmic function. So you can differentiate a log. Okay, here is the rule at the top here. If we have y equals ln, so that's log base e, of some function that we're calling f of x. When you differentiate it, here's the exciting news. There is no logarithm in the derivative. Okay, instead what happens is it differentiates into a fraction. Whatever the function is the denominator of the fraction, and you need the derivative of that function to be on the top of the fraction. That's it. That's how you differentiate logs. So question 1, find the gradient of the tangent to y equals ln of x at its x-intercept. So gradient means I need a derivative. If y equals ln of x, y dash is going to be, x is my function, okay, just x. So that means x is on the denominator, and the derivative of x, which is 1, is the numerator. So the derivative of log base e of x is 1 over x. Okay, but then we have to find the gradient at the x-intercept. What is the x-intercept? Yeah, we might know because we know this graph. But if you didn't know, you would sub in when y equals 0 into our equation. So that's 0 equals ln of x. How do I solve that equation? Remember, that's a log base e. So if you slide your base, the e will come over and it will be e to the power of 0 is equal to x. E to the power of 0 is 1. So x is equal to 1. Okay, that's not the answer. I have found what the x-intercept is. That's the x-intercept. Now I want the gradient at that x-intercept. So I have to sub that into my gradient or my derivative. So over here on the side, when x equals 1, my derivative is equal to 1 over 1, which is just 1. So the gradient at the x-intercept is 1. Yeah. It's the same thing. We usually write them as fractions because that's the way we see the formula. And most people prefer to work as fractions instead of negative powers. But I don't mind. It's the same thing. Okay, question B. Prove that y equals ln of x is always increasing and always concave down. Increasing means the first derivative or the gradient needs to always be positive. Yeah? Now this is a logarithm. A logarithm has a set domain, right? Remember the graph, logarithm graph that comes around like this. What is the domain of ln of x? X must be greater than 0, that's right. So in here, my domain is that x is greater than 0. So if x is greater than 0, my first derivative, which tells you whether it's increasing or decreasing, if x has to be positive, because it's a logarithm and x has to be positive, I can only put positive numbers into here. If I can only put positive numbers into here, that means my gradient is always going to be positive. Has to be, right? So I could say here that this is going to be greater than 0 when x is greater than 0. So that means that it is always increasing. Okay, that was the first part. Second part of the question says to show that it's concave down. Concavity. What is concavity talking about? Second derivative. So I'm going to do that over here. My first derivative, and I'm going to change it as Grace suggests. I'm going to change it to be x to the negative 1 so that I can differentiate the second time. Okay? So the second derivative, bring the negative 1 down, subtract 1 from the power makes a negative 2. Or in other words, negative 1 over x squared. Now again, if it's concave down, what does my second derivative need to be? Positive or negative? Negative. Concave down is negative. Okay? Is this always going to be negative? Yes. Because x always had to be positive anyway, but even if it didn't, it's got to be squared. So that denominator is always positive. 1 over something positive is always positive. So because of the minus sign, it is always going to be negative. Yeah? So we can say here that this is always going to be less than 0. Okay? So that means therefore concave down. Okay. Question 2 is some differentiating practice. Differentiate the following. Y equals 3x plus log e of x plus 4. Okay, so y dash, one term at a time. Derivative of 3x is 3. Okay, plus derivative of log e of x. The function is the x, so it goes to a fraction, and the x will be on the bottom, and the derivative of x, which is 1, goes to the top. Okay? That one. Okay, 4. What's the derivative of 4? Nothing. Gone. So we're finished. Okay, next one. All right, first term. How do I differentiate 6x squared? Bring the 2 down. 2 times 6 is 12x. Okay? All right, the next one. Ignore the 4 for a second. Differentiating the log will be x on the bottom and 1 on the top. This 4 is just being times with that. So you times the 4 to the top, which will make 4 over x. Is that okay? Great. Next page. Question 3, more differentiating. Looking more interesting with more brackets. Okay, so differentiating a log. Whatever the function is going to go to the bottom. 4x plus 3 on the bottom. The derivative of that goes on the top, which is 4. Done. Next one, b. The function goes on the bottom, which is mx plus b. What's the derivative of mx plus b? M. Done. C. The function goes on the bottom. The derivative goes on the top. What's the derivative? 6x squared, correct. And D, the minus 5 is sitting out the front. Times by my fraction. The 7 minus x squared, the function is on the bottom. The derivative on the top, what's that? Negative 2x. Then times negative 5 times negative 2 to make a positive 10x over 7 minus x squared. What do you think? Logarithm is pretty good, hey? Quick and nice. But then there's all the other types that we need to know as well. And we're always looking out for these guys. This is a product. This is a quotient. Yeah? Okay? X things multiplied together means product rule. So over on the side, let's do our u, which can be 3x squared. And the v will be log, or I'll write ln, sorry, ln of 2x. Differentiate both of them. U dash is 6x. V dash is, so 2x is the function, and the derivative of 2x is 2. 2 over 2x simplifies, though, to just be 1 over x. Okay, now into our VOOV. Y dash equals V U dash plus U V dash. Okay, timesing diagonally. We have 6x times the ln of 2x. Okay, then plus times the other way, we're going to be timesing the 3x squared times the 1 over x. Yeah? So 6x ln of 2x. The x squared, I can cancel the x off the bottom, so it would just be 3x. You could factorize if you wanted to. This is not, don't have to, but you could factorize a 3x out of that to get 2 ln of 2x plus 1. Yeah? Yes. Good. Okay. Question B. Let's do a quotient rule because we have x terms on the top, x terms on the bottom. So that's quotient. So we still need the u and the v. U is always the top. Log base e of 2 minus x. V is always the bottom. So 3x. Differentiating u dash. The function is 2 minus x. The derivative of the function is negative 1. Differentiating 3x, we get 3. Okay, so now we need our quotient rule, which is VOOV with a minus sign over v squared. Okay, so v times u dash. I'm going to times the 3x to the top to be negative 3x over 2 minus x. Is that okay? Then I times the other way. It's going to be 3 times log base e of 2 minus x over v squared, which is 3x squared. Okay, this obviously needs a little bit of tidying because I don't like having fractions in fractions. How can I get rid of this 2 minus x? Linda? Any other suggestions? As long as I multiply the same thing to the top and the bottom of the fraction, I haven't changed its value, right? So I could multiply the top and the bottom by 2 minus x. So in other words, all of this is going to be multiplied by 2 minus x, and the bottom is also multiplied by 2 minus x. Okay? That will mean when I times this in, so you're taking that whole thing, timesing it in, it will cancel off that denominator, right? So from that first one, I'll just have minus 3x. Then I times this with my second term, so I'm just going to make an extra bracket in here. It's going to be minus 3, that, and then my logarithm. Minus 3, 2 minus x, log base e of 2 minus x. Then on the bottom, 3x squared is the same as 9x with the squared there. But I also have to times that with a 2 minus x. So, I don't know, in some ways it made it bigger, but it did get rid of the fraction that was in my fraction. Yeah? Okay. Question 4. Simplify using log laws and then differentiate the following. Okay. Log laws. Okay. If I have things times, it means I can split them apart to be logs added. Yeah? So this would be equal to log base e of 7 plus log base e of x squared. I can still use more. There's another rule I can use. Which one? For this one. What can I do to this? The 2, that's right. Powers can come to the front. So this would be the same as log base e of 7 plus 2 log base e of x. Now, if I differentiate, y dash equals this is just a number. Differentiate it and that's gone. Okay, so here, differentiating this, the function is an x, it'll go to the bottom. The derivative of that is a 1, but the 2, I have to times the 2 to the top. So it would be 2 times by 1 over x, or straight to 2 over x if you're comfortable. Yeah? I mean, we could have done that question without the log laws. If we go back, say over here, differentiating it, my function would go to the bottom, 7x squared. The derivative of my function is 14x. So 14 over 7, there's my 2. 1x cancels, 1 doesn't. I get the same answer. Okay, but sometimes it's just much nicer to simplify with logs first. And it makes a nicer answer. Question B, let's do it again. We're told to use the log laws, so we're going to use the log laws. So the power is going to come down the front. This is going to be 2 log base e of 2x minus 5. Then, to differentiate, y dash equals, the 2 is sitting out the front, and my function is 2x minus 5 for the bottom. The derivative of that is 2, which will go to the top. 2 times 2 makes 4, so it will be 4 over 2x minus 5. Yeah, that's it. Question C. This one, we have to use log laws. We couldn't do this one otherwise. Okay? There's no other way to simplify. So, divided. If I have things divided here, it means I change it into logs that are subtracted. It would be equal to log base e of 4 minus x minus log base e of 4 plus x. Okay? Now those are things that I can differentiate. Okay, y dash equals, for the first one, the 4 minus x is the function on the bottom. The derivative of that is negative 1. And then minus, let's do the second one. 4 plus x is the function, and the derivative of the 4 plus x is 1. That's it. Okay, so that is 6G.